Hey guys, so we are going to be combining what we were supposed to do on Thursday and Friday together into one day. So right now, this top part looks a bit blurry, but if you open up your notes, you can see it very well. Basically, what I wanted you guys to do was I wanted you to figure out how to say these. So this first one is going to be, what is the limit of f of x as x approaches a number from the left? Or you could say it as, what is the limit as x approaches a number from the left of f of x? The middle is, what's the limit of f of x as x approaches a number from the right? You could also say it the other way. And then the last one is, what is the limit of f of x as x approaches a number? And it doesn't tell you what side, so you have to check both the left and the right side. So I mentioned it on the first video, but we do need to determine the difference between infinity and does not exist. Remember, infinity is under the umbrella term does not exist. Why is it under does not exist? Well, technically, your answer to a limit question has to be a number, and infinity is not a number. But there could be the case where AP will ask you a limit question, and let's say the answer that you get is infinity or negative infinity. Negative infinity or infinity may not be an answer choice, but does not exist would be. So I just wanted you to recognize that if you get infinity or negative infinity, that it's under the umbrella term of does not exist. It could also be the other way, where you do get infinity or negative infinity, and College Board actually has that as an answer choice. You won't see does not exist. So what I just want to mention is you will never see both does not exist and infinity or negative infinity in the same answer for a limit question. Okay, well, now they're going to give you some questions that don't have graphs. They might give you a table instead. So let's look at this one. Let's just determine what it's even asking for. So I noticed that I have these x values. My x values, first off, they're very specific. And so it seems as if I'm zooming into a certain number, right? And then if I look at my corresponding y values, I have these y values except for a certain value at what? Well, I don't have a value at 1, so we can conclude that this question is asking for the limit of f of x as x approaches 1. So how come I didn't say that this was a limit of f of x as x approaches 1 from the left? Well, the reason why I didn't specify was because look at this table. Do I have values from both the left and the right side? I do, which allows us to conclude that this limit is probably asking for the value as x approaches 1 in general. Okay, let's look at the second one. We have a table of sine of 1 over x, and we want to know what the limit is as x approaches 0, I believe. So the first thing that you would want to do is we can try and make a table. Luckily for us, the table's already here. But the thing is it's going towards 0. I think it's only going from one side. And the numbers, the corresponding y values, they seem to be doing something different than what we've normally seen before. So what else can we do? Let's actually try graphing it and visualizing this, because that's what we did on the first day. So truthfully, I just graphed this in GeoGebra. This is the function of sine of 1 over x. And we want to know what the limit is as it approaches 0. And since it didn't specify, we're going to check from both sides. There's a lot of things going on at 0. So if I honestly tried zooming in, what you would get is you would still get more and more oscillation. Meaning no matter how much you keep on zooming in, you will still see a pattern of it going from +1 to -1 and back and forth. So in this case, the more that we keep on zooming in, the closer that we get to 0, we still haven't been able to pinpoint what number this function is going to, right? Because it keeps on following this pattern of oscillation. That's when we just say that it falls under the umbrella term of does not exist, because it'll continuously oscillate, meaning it'll never reach a specific one number. Okay, so what we are going to conclude is after seeing the graph, you recognize that this function oscillates, therefore we can say that the limit does not exist. So now let's talk about the 3 different ways that we can conclude a limit does not exist. The first one we figured out yesterday, and that was when the left limit did not equal the right limit. The second one is on a technicality, and that's going to be whenever you have infinity as an answer, because remember, infinity is not a number. And then the last one is if the function oscillates or has some kind of noticeable pattern to where it'll never reach a singular number. So if you ever fall into one of these 3 answers, then overall your limit just does not exist. So let's go on to this next table. It doesn't even give us the y values, but it gives us a function. What do you think we should do first? We should probably just plug in these x values into the function to get my y value so that I can figure out what the limit is as x approaches 2. So I'm going to let you guys do that, and then I want you to write the correct limit notation and the answer, and then we are going to move on. All right, let's go back to yesterday's problem, and we learned that we can use tables to help us kind of figure out points as they are getting closer and closer to a certain value, and our example was to 2, right? But sometimes when we make tables, they take up a lot of time, and definitely during the test, you're not going to have a lot of time to make a table, so there are faster ways to find limits. The first way that you can find a limit, and this is only if it works right away, is to plug in the value that it's approaching into the function. So for example, with 1a, all we're going to do is we're going to plug in -2 into our function and see what we get. So as you can see, all I did was I just plugged in -2 every time I saw an x, and there was nothing wrong with it because in the end, I just got a number. I got 13, and so that's my answer. So now I want you guys to try 1b and 1c, and 1c does require you to remember trig values, which I hope you guys do. All right, so if you got 4 and -1 on those 2 questions, then you are right and you are a pro at plugging in numbers. But the sad thing is honestly, limits aren't always going to be that straightforward. Sometimes you're going to have to do more because you're not always going to get a number right away, and that's where we go to number 2. Okay, so sometimes you're going to plug in that value and you're going to get 0/0. Well, in that case, that's not your answer. You're going to have to do more. You are going to have to factor or manipulate the function algebraically somehow to simplify it. So we're going to try this with yesterday's problem. What I'm going to do first is I'm going to plug in 2 and see what we get. And when I did it, I ended up getting 0/0, right? So the next step that we should do is we should probably factor. And when I factor, I realize that I can cancel out x minus 2. So now I can say that my original limit question is equivalent to the limit as x approaches 2 of just x minus 1 through simplification. And then once I've done that, once I've simplified, then I can plug in my value again, and I ultimately get that my answer is 3. And I know from yesterday that's my answer because we figured it out through the table. So yes, while factoring and simplifying are pretty simple, one thing that you need to be careful of is a linkage error. And the reason why is because if you write it incorrectly, you're going to get points taken off on your AP test. So is the statement that I just wrote a correct statement? Does the limit of that function as x approach 2 actually equal x minus 1? So the answer is no, because by writing it like this, what I said was I said x squared minus 3x plus 2 divided by x minus 2 is the exact same thing as x minus 1. And I know this isn't true because in order to get from the left side to the right side, I canceled out x minus 2, right? Now, if I actually graphed these 2 functions, they're very similar, but there's something different between them. Okay, so right here, I graphed the 2 equations on GeoGebra, and visually, I can see that they have the exact same slope. The 2 lines are on top of each other, right? But here's the difference, is that on the original function, when I try to find a value at x equals 2, there's technically an open circle. But on my second simplified function, when I plug in 2, I actually get a value. So that's why you can't say that these 2 equations are equal to each other because of that difference. Okay, so now visually you know why those 2 don't equal each other. So the real question is how do I write this statement correctly? All right, in this new statement, which is correct, what is the only thing that I added to change the statement? Hopefully you guys recognize that all I did was I just added a limit statement in front of my second function. This is a true statement because if we go back to the graph, what am I looking for? I am just looking for the limit as it approaches 2 from both sides. So on both of my functions, all I care about is from the left of 2 and from the right of 2, what number are they approaching? Well, on my green function, the first function, I am approaching the y value of 1, even though there's a hole, because remember, there doesn't actually have to be a value there. The left side just has to equal the right side. And for my blue function, it's 1 for the exact same reason. So if you can just remember to be careful about linkage errors, then algebraic manipulation is going to be a breeze for you. So let's do some practice. So the first thing that I'm going to do is I'm just going to assume that it's a normal function. I'm going to plug in -2 into this first example. And once I plug it in, I ended up getting 0 over 0. So once I got 0 over 0, that should have told me, it doesn't work. I didn't get a number right away, so I should probably factor. Okay, so once I'm here, I recognize that I can cancel out x plus 2, but I'm not going to do that just in case they take off points. So here's what I'm going to do instead. I'm just going to say that it equals the limit as x approaches -2 of x minus 4. Okay? Like, you know that the x plus 2's can cancel out. You don't really need to show it, and I wouldn't want you to get points taken off anyway, so I think this is a safer bet. And once you're here, now we can just plug in that x value, and we get -6. Okay, I want you to pause this video and work on 2b now. Okay, so I plugged in 0, and I got 0 over 0, which tells me that I should factor. So I factored the top by taking out a 5x, and I factored out the bottom by taking out an x. I can't really cancel anything right now, but I recognize that the numerator has a perfect square. So x squared minus 1 actually turns into x plus 1 times x minus 1. Okay, right here I recognize that I can cancel out a x plus 1 and an x. So instead of actually canceling them out, I'm just going to say that it equals the limit as x approaches 0 of 5 times x minus 1, and then I'm going to plug in 0, and my final answer is going to be -5. So honestly, I'd say rule of thumb is if you cancel something out when you're algebraically manipulating, you should always follow up with the limit as x approaches whatever. All right, pause the video and work on 2c now. All right, so for 2c, you should have gotten 0. Hopefully you did. I want to bring up another point. This first line right here, all I did was I just checked if it equaled 0 over 0. And the moment that it did, I did not put an equal sign right after. So if you notice, I don't have an equals because this first line was just me checking to see if I needed to do anything else in terms of algebraically manipulating. If you magically put an equals, then what you would have said is you would have said that the limit of this function equals 0 over 0, which still equals the limit of the other function, which equals the simplified one, which equals 0. So what you would be telling me is you would be saying 0 over 0 equals 0. And we know that that's not right because 0 over 0 is something completely different, which you'll learn on number 4. But yeah, they just don't equal each other. So again, just be careful and be conscious of where you put your equal signs. Okay, so let's say that you tried to plug in a number, you couldn't get an answer right away, then you tried to factor, and you still didn't get a number. You probably got a number divided by 0, which leads us to our third type of determining what kind of does not exist is it. Is it does not exist because it goes to positive infinity, negative infinity, or because the left side doesn't match the right side? So what you'll have to do is you'll just have to check the left limit separately and the right limit separately and see what they are. And again, remember, if your answer is infinity, you can put does not exist. And in fact, that's the technically correct answer. But if the answer is does not exist, I don't necessarily know that it does not exist because it's infinity or if it's because the limits don't match up. So that's why we have to kind of further do it just in case they want a little bit more explanation, or if I ask you, why is it does not exist? Okay, so with this first problem, I plugged in -3, and after simplifying, I ended up getting 0 over 0. Once I have that, I know that I need to factor, so I'm going to manipulate. But remember, I'm not going to put an equal sign there because me saying that it's 0 over 0 is just a statement that tells me that I need to do more. Okay, so in my next step, I factored it out. I did not cancel out, but then I set it equal to the limit of the simplified version, and I got a number over 0. So for sure, the answers does not exist, but I just want to double check and I want to know why it does not exist. So we're going to have to go back to the basic definition of what a limit is, and I'm going to have to see, does my left side equal my right side? Okay, so I started off with a limit from the left side, and I said the limit as x approaches -3 from the left of my simplified function. What does this equal? Well, what are we actually doing when I am approaching from the left? Remember, I am getting closer and closer to a number from the left. So what's a number that's really close to -3 from the left? I'm going to say it's going to be -3.001 because remember on the table, that's kind of what we did. So I'm going to use this -3.001 just as a reference when plugging in this number into the simplified equation. And honestly, all I care about are the signs. So when I plug in -3.001 on the top and I subtract 1, it's going to be negative. And when I plug it in on the bottom, it's still going to be negative, which means that overall I'm going to have a positive infinity. I'm going to do the exact same thing for a right limit. So when I'm trying to find the right limit, I'm going to want to plug in a number that's really close to -3 from the right side. I'm probably going to plug in -2.999. And when I do, I'm going to plug that into the function. My numerator is still going to be negative. My denominator this time is going to be positive, which means that I'm going to have a negative infinity. So my answer overall is going to be does not exist. But the reason why is because my left limit does not equal my right limit. All right, please try the next practice problem. Okay, so once I plug in 0, I already get a number over 0, and this function alone, I can't really factor it, so I'm going to jump straight into checking the left limit and the right limit. Okay, and so for my left limit, I plugged in a number really close to 0 from the left side, so I did -0.001, and I ultimately got that it went to positive infinity. For my right limit, I plugged in a number close to 0 from the right, so I plugged in 0.001, and I also got that it went to positive infinity. So, since my limit of the left side went to infinity and the limit on the right side went to positive infinity, I know that the limit of this function overall goes to positive infinity, but I'm going to say does not exist because technically infinity is not a number. Okay, so the last thing is you've tried to plug in a number, you tried to factor, it didn't work, you still somehow managed to get 0 over 0. Well, then at this point, we're just going to say that it's an indeterminate form, and we're going to leave it like that because we will learn about how to solve it at a later point. All right, now let's flip to the back. Okay, so what if we are given a piecewise function? This is really nice because we're just going to look at what they already gave us. Let's look at 5a. It's asking to find the limit as x approaches 1. Does it say which side? No, it does not, so we have to check from both sides, the left and the right. So when I check from the left side, which function am I looking at? I'm only looking at the x squared minus 4 because that's to the left of 1. And when I plug in 1, I get -3. Okay, now I'm going to do the right side. Which function am I looking at? Just the -3x plus 1, because that's to the right of 1. I plug in 1 and I get -2. So since -3 and -2 do not equal each other, then that means that the limit as x approaches 1 of this function does not exist because both sides don't equal each other. All right, try 5b on your own. All right, here's my work. Hopefully you got 6. But aside from that, another question that I could actually ask you is, what is f of 2? F of 2 is 4, but the limit is 6. So again, just want you to know the difference between the two. And then the last type of limits we are going to do are the ones as they approach infinity or negative infinity. You guys actually did this before. These are basically horizontal asymptotes. And what you learned was an acronym. Bobo Button eats DC. And to just refresh your memory, that stands for bigger on bottom, y equals 0. Bigger on top, there is no horizontal asymptote or infinity, and exponents are the same, so you divide the coefficients. So I want you guys to try 7a, b, and c. So hopefully you got these as your answers. I'm going to do 7f with you guys just because it's going to negative infinity. So again, we know with these limits to infinity, the only thing that I care about is the highest power, right? So on my numerator, I have the square root of x squared. Since that's my highest power, what I'm going to do is I'm actually going to square root it, and I get an x on the top. I don't care about my second term because it was a lower power anyway, but when you take the square root of something, you always have to account for the positive and negative, right? So technically, this becomes the limit as x goes to infinity of plus or minus x over 2x on the bottom. Remember, I only care about my first and highest term. So in this case, once I have this, where am I going to? Am I going to positive infinity or negative infinity? Since I'm going to negative infinity, I'm going to take that negative x, and so now I have the limit as x approaches negative infinity of negative x over 2x, and I get negative 1/2. All right, we definitely learned a lot from this video. Now I want you to work on the practice that I am going to assign so that you can utilize these lovely skills that you have just learned in this 15-minute video. Thanks for watching.